One of the most confusing ways to teach fraction division is by teaching it with tricks like cross multiplication or keep change flip, in which the division problems magically change to multiplication problems, and it's often where students get confused about either where to put the products or how come the second fraction is flipped. These tricks are often taught with no reasoning. Unfortunately, we just hear things like, my teacher said to do it this way. I guess the myth here is that you have to use one of these tricks to divide fractions. And the truth is, you don't. Many times there may be a much more efficient way to think about it. Like this problem, for example, is just one number divided by itself, so the answer is 1. And if we look at the relationship between the fractions here, we just need to know how many 1/4 are needed to make 3/4. So 3. Now, this one's a little bit more confusing, but really it's just dividing the numerators just like the others. And this one, though, is a little bit different. So how can we make sense of this based on what we know from the previous 3? Well, one of the reasons the last problem was so challenging is because it looks different. It's the only example where the fractions don't have common denominators. But we can rewrite it with common denominators, and suddenly it makes a little bit more sense. Or maybe somebody notices that fraction division is just like fraction multiplication. You can divide straight across. 3 divided by 3 is 1. 4 divided by 4 is 1. And the answer is still 1. Or 3 divided by 1 is 3. And 4 divided by 4 is 1, giving us the answer of 3, just like before. This one, like I said, is a little bit more challenging. But 3 divided by 4, we could think of that as 3/4. And 5 divided by 5 is 1. And 3/4 divided by 1 is 3/4. And here's that tricky one, but not as tricky now when we think about it this way. 4 divided by 2 is 2. And 15 divided by 3 is 5. And we got 4/10 before by using common denominators, but 2/5 is an equivalent fraction, so it still works. Now, we can ask students to begin looking for patterns in a way that they notice about each of these examples, and we can facilitate discussions around the patterns they see to build deeper understandings. We can also provide students with opportunities to see what's happening in the division of fractions and why it works. And there's a really good way to do this. You guessed it, through context. So here's a simple little context for dividing fractions. And when we try to take a context like this and make sense of it, it's often really helpful to draw a diagram to help us understand what's going on. And in this problem, we have a pail with 2/3 of a gallon of water in it. And with this water in it, the pail is 7/8 full. So using this context, we need to find out how much water is in a full pail. And to find out, it would be really helpful to know how much water is in 1/8 of the pail. Well, if 7/8 of the pail is 2/3 of a gallon, if I divide that 2/3 by 7, that should give me the 1/8, because each of those 7/8 is a part of that 2/3 gallon. So if I divide by 7, that'll give me the 1/8 of the pail. And then once I get that answer, whatever it is, I can multiply that by 8 to get the full pail, or 8/8 of the pail. So I've got 2/3 really times 8 over 7. Here's a bigger picture of what we just did. It's at this point where students will likely notice that the divisor 7/8 has been flipped. And this is where the term reciprocal should be introduced, because now there's a need for it. By teaching through context, students can make sense of the problems and discover the mathematics. Now, with a little help from the teacher, students can reason through more contextual problems to determine that this works all the time. And the context helps students make sense of why it works. And for that reason, students are more likely to remember what they understand. The most important job a student has in math class is to reason. So let's lose this tired old rhyme and build students' understanding of the mathematics that they're doing. It makes sense, just like mathematics.